All right, scholars, we're going to pick up with the back end of our statistical journey. Today, we are going to determine an estimate for the population mean with a margin of error using sample means from random samples. So I can understand that sample means that are normally distributed follow the same pattern as sample proportions. So we can, instead of obviously increasing the volume in which we are calculating data, instead, we could take multiple different samples of relatively small size, estimate their means, their standard deviations, their margin of errors, and to a pretty concise degree, extend those same findings to represent the entire population. I'll know I've got it when I can calculate the mean and standard deviation of sample means and use the information to estimate the margin of error. Let's begin. So in the next activity, you're going to roll a standard number cube 35 times. I would like for you right now, though, to draw a dot plot that shows the distribution of values you might expect for the rolls and explain your reasoning below. So you decide over 35 rolls what values or what outputs, what outcomes do you anticipate happening from the standard number cube rolls. Think about it from a theoretical perspective regarding probability. Is there an increased likelihood of a particular number coming up, or does each number have the same probability as another? Those two statements should inform you regarding your dot plot distribution. And if you rolled the number cube 1 million times and found the mean of all the values, what do you expect for the mean? What do you think the average number will be? So as you can see here, we will roll our dice and it will generate a value for us. Every 5 values, find the mean. So when we say 1 through 5, those are your first 5 values. So I would have 4, 2, 1, 2, 5. So 4 plus 2 plus 1 plus 2 plus 5 is going to be 14 divided by 5, which is going to be just under 3. So we can say like 2.8. Right, so for those first 5 rolls, my average value on the dice was approximately 2.8, almost 3. We're going to do that for the 35 rolls. I should say 31 through 35. All right. Using the data from our class, we have this type of distribution regarding the average value for 5 rolls. Using that dot plot, what do you notice about the shape of the distribution of the means? And using that same dot plot, what do you think is a good estimate for the mean of all 140 rolls from your group? How does that value compare to your estimate from the warm-up? All right, within this next activity, right, so it's over 2 slides, we have 4 different scenarios. So as with the means of sample proportions, the means of sample means are usually within 2 standard deviations of the population mean when there is a large sample size or when the population distribution is approximately normal. So you have 3 tasks before you. These are the sample means to estimate the mean of the population, find the standard deviation of the sample means, and then use that value to estimate the margin of error. So let's take, for instance, the mean number of claimed UFO sightings are shown for 13 samples of 5 randomly selected months. So back in the day when dinosaurs roamed the earth, we would calculate these values by hand, but we exist and operate in the 21st century. So I'm going to show you a little bit of statistical technology. We can define on Desmos a data to be a part of a list by typing a letter to reference that list. Can you do? No, you can't do a word, right? So a letter to represent that list. Okay. Brace, which is right next to the letter P symbol, then input your list, and then close. So our first value or statistical measure that we need to calculate is the mean. So I can literally type mean of that list A, and I have my output here of 549.67. Right? So the mean of the population based on these sample means is roughly 550, right? So 550 UFO sightings, that's the average. If I want to calculate standard deviation, I would do std dev of list A, which is approximately 5158.09. And then from here, I'm actually going to leave the margin of error blank. There is not a, I guess you could say, statistical function in Desmos to calculate margin of error, because the margin of error is contingent upon the value of the standard deviation. So using that, since we have the standard deviation, you should be able to calculate the margin of error quite precisely. So you'll follow that, since I did this activity, this context for these three contexts here, and then a bit of reflection questions here. Okay, kind of gauging your understanding of what happens when we are experimenting using sample means rather than the data from the actual population. So work your way through these two slides, and as always, if you run into a bit of trouble, we will have a conversation together in class, but the lesson summary does give a nice, very detailed breakdown of the content that we've discussed in this video. That's where we're going to pause and pick it up together.